So I guess we can always wait for her, or I can just pull up mine in the meantime and then.
Yeah, if you want to pull it up, go ahead. Let me pull it up. Go ahead, take care.
I'm going to share my screen. This is just the one that I've already taken.
Right.
Can you see my screen?
Yeah, I can see it.
Those two are, I didn't get 100%. I did miss a few, but
I did too, and I was kind of confused about a couple of them. So hopefully we can figure it out.
Okay. Well, Chris is here, so if we need help.
Awesome. I'm glad he's there.
Okay, so the first one, did you get that one right too? Which hypothesis
Yeah.
involves? Okay.
Yeah, I got that one right.
And then the fourth one, it says, remember that the p-value is the probability of obtaining sample statistic at least as extreme as the one that was actually observed when computing the p-value, which hypothesis to use. Yeah, I got confused on the null hypothesis and the alternative hypothesis a little bit, but did you understand it that well, or was it?
No, this was I was confused about most of this quiz. So it was I was trying to go through it, and I remember reading through it and doing the assignment and the individual preparation assignment, and I was like, well, let's see. Hopefully, I can do this. But I think what I was confused about on this one was when I would read the description in the book and then go and look at what null hypothesis and alternative hypothesis. I think it's the way it's worded. I think I'm just getting messed up a lot.
Yeah, I can see that because the null hypothesis is you always doesn't it mean that it's true unless you can prove it wrong, or you're trying basically.
Or you're trying to.
Yeah, you're trying to prove it wrong, and so I think that's the null hypothesis, is that it's true unless proven wrong, or true unless proven wrong, and then the alternative is you either fail to prove it wrong or you have proved it wrong. It's never like correct. I don't know, something like that.
Yeah, something like that. Yeah. But the first time I took this one, I got that one right. So I was like, oh, at least I got it right.
Okay.
Don't understand it then.
Okay. So number 5, then, which of the following represents alternative hypothesis for a two-tailed test, and that was
the mu is not equal to 10.
Because this greater than and less than it would be either right-tailed or left-tailed.
Left-tailed.
Yeah. And then this one, what would the graph look like? Would it just be a normal, like, curve, right?
Mm-hmm.
Okay, and then number 6, which of the following represents the alternative hypothesis left-tailed test? So that's always going to be
it would be like, what, less than 10, or the top one.
So in elementary school, I was always told about the alligator, and it always was a bigger number. But I'm really confused because I feel like you're supposed to be doing the opposite of what the word problem is asking. So if in the word problem they think it should be greater than, then you pick the word sentence that is the opposite. I don't know. That's what I was noticing.
Yeah, it's weird because when I did the FDMAT when I was 8, like a couple semesters ago, and I was like, it doesn't make sense to me anymore, the alligator. I was like, I think it has to do with the way the arrow's pointing.
Yeah, because now it's
less than or greater.
Yeah, like, I know, because I was like, that doesn't make sense. That's well, we'll have to relearn everything that we just throw it out at the window.
No.
But let's see. Okay, so number 7, which of the following represents the right tail?
That's right.
Okay. So
I got that one.
did you get 8? Okay.
Yeah.
And then 9.
9 is fine.
So in rejecting the null hypothesis, you would prove the p-value to be, what is that, greater than, what does A stand for?
A is for, oh gosh, what is this? It's the alpha symbol, but it's the significance of or something like that. It's either like 0.05 or 0.01 or something like that.
Okay.
I think that's what the alpha stand, or the A, the alpha stands for.
And then, oh, sorry.
I got this one wrong too.
Let's see.
I said the same thing. I said the average claim amount is not equal to 59. That was wrong.
So which of the following, okay, let's think this one through then. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was 1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. So I think that's why I was like, which of the following would be the appropriate alternative hypothesis? I don't know.
Insurance companies are running its current policy rates. Originally setting the rates for the lead that they claim amount was 1,500. Concerned that the true mean.
So maybe it would have been greater than? Maybe it was the one right below that. The average claim amount is greater than 1,500?
Let's say that they're concerned that the true mean is actually higher than this. So probably greater. I'll try. I'll try.
Or here, let me go ask Chris. He would know, because I think I don't know. That one really confused me because it was, I don't know. Okay.
No, I understand. I feel go get.
Read the word problem and then
number 10.
Yeah, that we both got that one. So you would think that it would be the average claim.
Let me read it. Okay, so in this one, the true mean is actually, if they are concerned that the true mean is higher than this, then they now believe that the true mean is greater than 1,500. So the alternative hypothesis, let's see. Did you put the claim amount is not equal to 1,500 as well?
Yeah, I did the same thing.
So I believe when I talked to Alyssa about this one before, I thought it was that third response.
Okay.
The average claim amount is
greater than 1,500. Okay.
Is greater than 1,500. I believe that's correct.
Okay.
Because it's what you're trying to. There's the null hypothesis and the alternative hypothesis. And the null hypothesis is just kind of what the status quo is. It's what you expect to get. And the alternative hypothesis is it's the opposite of whatever that is.
Okay. All right, thanks. I appreciate it, man.
like, let's see. Yeah, that's I believe it's C. If I had to guess.
Oh, that's fine. No, don't worry about it. I appreciate your help. These ones are kind of difficult. So.
Yeah, no, these things can get really confusing. So, basically, null hypothesis is if nothing changed, that's what it would be.
That's what it would be.
And then alternative hypothesis is whatever you normally it's whatever the opposite of the status quo is.
Yeah.
In this case, it's the alternative hypothesis is what addresses their concern. So yeah.
Okay. All right. Well, thanks, Chris. Thanks, man. Appreciate it.
So, like for the next question, you got correct, right?
Yeah, I got that one right.
Right, and elicited too. So the average claim is equal to 1,500. Yeah. So it's not always just like whatever it's not. In this case, they're looking for something very specific.
Okay. Okay.
It's like it's a one-tailed test that they'll.
Okay. That makes sense.
Sorry, that was my son.
That's okay. He sounds like he's having fun.
He is. He's taking our water jug and using a spoon and hanging on it. So.
Cute.
I texted Anna again. She didn't respond, but we'll just keep.
Yeah, me either. I don't know. I hope she's okay.
Sorry, I never texted those answers. I totally spaced it. I meant to ask Chris, but then I figured you probably knew it since you
Yeah, it's actually I played around with it more and I finally figured it out. I figured out the rest of the problems,
yeah.
and then I was like, I went in to do the exam and I was like, oh, none of these are on there. So I had to really. I mean, I studied a little bit and I went in and did. I did okay. I did all right, but I didn't do as good as I thought I was gonna do.
Well,
but I didn't fail. So
yeah, that's good. A majority of them were like, they weren't really mathematical, but most of the first half of it was just like, it's like, what's the alternative or what's the steps in the, the 5-step process? First, you have
the
to
statistical,
yeah.
Yeah, it's like I don't remember. I was like, design the study, and like other ones. I was like, I try to think of the acronym of Daniel and stuff, but
yeah, me too. I was like, David, or I'm like, that's not even the right person.
It was interesting, but oh well, it's over. Luckily, at least the first one is.
Yeah, I didn't do the same. I wasn't it wasn't terrible, but it could have been better. I'm like, I'll study differently next time.
I do have a meeting with her tomorrow to talk with her about that.
Oh, good. Yeah, to get some of your questions answered.
Yeah, so I make sure that I'm okay to keep going on in the class. I'm not going to die.
Yeah, I want to know what you are doing wrong in order to get better at it. Let's see. The insurance company assumes the distribution of the sample mean is normal. Did you get this one right?
Yeah, I got this one right.
Okay.
Yeah, that was good assumptions. And I was like, okay, that one's right. And I was kind of, you have to just, the second one kind of falls, like 13 kind of follows the same thing. So it's the essential limit.
Yeah, that's what I was thinking too. I'm like, how low is too low to... So I guess 5 is too low, but anything maybe above that, like 10 or above is, I don't know. I'm still kind of...
Yeah, because I think anything that's, I think it's 30 or something like that.
Yeah.
No, that's something, yeah, something like that.
Okay. So the insurance company was okay, so we'll move forward then. 13. Did you get this one right?
Yeah, yeah, I got this one right.
This one?
Yeah, I got 14 right. So I got this one right.
16?
I got 15 right, but I did not get 16. And I don't know what I did wrong.
You didn't get 16 right?
No, I don't know what I did wrong. Was I supposed to plug in the 0.900 in the applet?
I think that is, yeah, and then round to the 3 decimal places.
So I did that, and was I supposed to just choose the left side of the applet to get that answer? Because it looks like that's what you have is 0.184, and I had both. I don't know, maybe Chris could explain this maybe better. I'm not sure what I did right or wrong.
Let's take a break for a second. Send Anna another invite. She just texted me and said she tried 2 times to join the meeting.
Okay, yeah, let me do that.
Oh, sorry. You want me to stop sharing my screen?
I think you're okay. Okay. You can if you want to. That's totally fine. You can share hers when she comes in.
I just told her that you were sending an invite.
Yeah, I did it already, actually.
So how was your daughter? Was it your daughter or your son's graduation?
It was kind of like both. My daughter did like a medal ceremony for. She did a whole bunch of like assignments and projects this year for her 3rd grade. So since she did so many, they gave her gold medal for it.
Aww.
And so, and then my son, he did so they're both, he's in kindergarten and my daughter's in 3rd grade. And so my son in kindergarten, he did like a presentation. I think it was about, I don't know, basically about the U.S., like American stuff. So I was like, they sang like Yankee Doodle Dandy, and they sang, they did the national anthem, they did the Pledge of Allegiance and stuff like that. So they did like an American themed presentation for the last day of school. He finished his last day of school today, and then my daughter Joy, her last day is tomorrow, even though she had her ceremony today.
That's awesome. I bet that was fun to watch them.
It was fun to watch. Yeah, they're getting older. Yeah, they get older, I get older, so it's kind of like, yeah.
Okay, did you get Anna's text? She said, just open my Hangouts, Chad. Sorry. You might have to send it one more time if she wasn't in Hangouts.
Let me try. I'll try one more time. Alright. I hope I have the right. I sent this one here before and she's been able to get in before, so.
Yeah, hopefully it's nothing on her end.
Yeah, I hope not either.
Hey, Chad.
Oh, is she
How's
on?
it going? Yep, there she is.
Hey.
Hi, Anna.
Hey.
So sorry about this morning.
Oh, no, don't worry about it.
Okay. Did you already take the quiz?
I'm taking it right now.
Do you want to share your screen and we can go over it with you?
Oh, did you guys take it already?
Yeah, we were
just. I took it.
Yeah. Just once. Well, we took it like not right now, but we took it previously before the meeting.
Yeah.
Can you see? Huh?
I took mine on Saturday for this lesson. And
Can you see the screen already?
Yeah, I can see you. Yeah, you're sharing your screen.
Yeah,
Oh,
you're
okay.
doing that. There you go. Uh-huh.
Okay. And 3, the null hypothesis.
Let me scroll back up.
Yeah, that's right. Mm-hmm.
Number 4, when computing the pieces, do you assume to be true the null hypothesis?
Uh-huh.
Which of the following represents the hypothesis for a two-tailed test? The third and third.
Mm-hmm.
Following represent the alternative hypothesis for a left tail test.
Yes.
So that would be.
Yeah, the top one. You're right.
7 would be right tail, so it would be. It will be. These will be bigger than.
Yeah, that's right. Greater than the 10. Mm-hmm.
The 10. 8. Which relationship will result in failing to reject these?
Mm-hmm.
Meaning that's not true. That will be if p-value is bigger than 0.05, whatever value they give you.
Right.
Yeah. And then in rejecting the meaning that null hypothesis is not true will be less than p. Then alpha? I don't know.
No, you're right. That's the right one.
Okay. And then this is where I stop. I was doing this one.
And so, actually, this has been helped us with this one. So,
an insurance company's review is current value of one of your second to 1,500. So
we said that same one, the average claim amount is not equal to 1,500, but it wasn't right the first time. So, if you read the thing, it says, an insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this.
So the 8.
They want to. Yeah, they're trying to find the alternative hypothesis, so they're looking for something different or something like that. I remember trying to remember what Melissa's husband Chris said about this, but he mentioned that he believes it's the average claim amount is greater than 1,500 because you're trying to find something, the mean that's actually higher than that. So we kind of went with the average claim amount.
Sorry, but I can hear you very well. I don't know why. The voice just go on and off.
Okay.
So this is what you answer right here?
No, yeah, so it's not the average claim amount is not equal. It's not that one. So what it says, they're concerned that the true mean is actually higher than the 1,500.
Average claim amount is greater than 1,500.
That's what we think.
Yeah, because then the alternative hypothesis would be bigger than 1,500.
Yeah, something's not equal to the status quo, so it's like it's different. So it's going to be something different. It's not going to be equal to it, but it's going to
if it's not. Yeah, I get it. Which of the following would be the appropriate null hypothesis? It would be HO equals.
Right there.
So remember, HO represents the null hypothesis. HA represents the alternative hypothesis.
Yeah. So HO is 1,500, and then HA is higher than 1,500, greater than. Right?
Yeah, that's right.
So in 11, did you guys get this one right?
Oh, number 11?
Yeah.
I put the average claim amount is equal to 1,500, and that was correct.
The first one, right?
Yeah.
Oh, okay. So 12. Oh, too many questions. Well, oh no.
There's a lot more.
Sorry. Okay, the insurance company randomly select n equals 40 claims and calculates the sample mean of 150. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? It is a good assumption since the sample size is large. It is not a good assumption since the sample size is small. It is a good assumption. The population is normal. Not a good
assumption. For number 12, I put the first one. It is a good
assumption. Yeah, that's what I was gonna say. So it's 1,650. It's really big. That what you guys put?
Yeah, well, yeah, because of because their sample means pretty big too. It's about 40 claims or whatever. So kind of went with the fact that it was like.
The 13, whether or your answer to the previous question. Nearly two. So the law of large numbers.
The law of large numbers signifies that I think the closer it gets to the mean, the larger the population is. But I think it's a central limit theorem because of
We do the following is the test statistic as defined in this lesson. S?
No. It would be the Z-score. The Z.
Z?
Yeah. Yeah, that's because that's what you're finding. That's what you're finding. In the book, it talks about this. The test statistic is what you're finding. You're finding the z-score. Basically, you're just taking that that formula we've used for the last couple weeks, and that's basically what the test statistic is.
Z equals x minus u divided by q square root of n.
Divided by the square root of whatever number. Yeah. Mm-hmm.
Okay, so the historical mean of sales receipts at a grocery store is 150. So the mean is 150 with a standard deviation of 40. The store manager suspects that the average. So HO equals 150. HA equals, no, it doesn't equal. It says
less than 150.
So this sign like this, right?
Yeah, so if you look at the...
Oh, there it is.
Yep.
It sets up a hypothesis with a hypothesis. Okay. Mm-hmm. She will use a level of 0.05. She then takes a simple random sample of 36. So that's N.
Uh-huh.
You're tired too, huh?
Yep.
From her store and computes 144. So what score associated with the test? So that's the formula, right? So Z equals 144 minus 150 divided by 40 divided by the square root of 36. Is that right?
Yep.
Okay, let's do it quick. Then 144 minus 150 equals minus 6 divided by 40. And then 40 divided by 36 square root 6.6666. So 6 minus divided by 6.66. So Z equals minus 0.900. And then you go to the applet, right? Or you just...
Or you can plug the z-score into number 15. So put that z-score in there.
Oh, so minus 0.900.
Yes.
Is that right?
Yeah, you're right.
That's the p-value. That's the area. So I go to the applet, right?
Z-score, or go to the applet and put in Z-score, and then you only highlight, because the problem is asking for the average has decreased, so you only highlight the left side, and that should, once you round to 3 decimals, that should give you your answer.
Hey, so how do you know that? Because that's when I got wrong. I was going to ask you about that. Listen, how do you know you're supposed to use the decreases because of the negative z-score?
No, back up in the problem. This was Chris was explaining it to me, that it's saying the store manager suspects that the average has decreased.
Oh, okay.
That's kind of your clue. If you refer back to those word problems, are they asking for a greater than, less than, decreased, higher, those kind of things, and then.
So, okay, because I was thinking about this because I looked in the book earlier too. Because they did one, kind of like a similar problem in the book and on the assignment, and they highlighted both. They highlighted both sides, and I'm like, well, I'll highlight both sides. I put it in. That was wrong. So I was like, okay, maybe I'm wrong. So I never.
Well, I did too. I wasn't sure. But I just got done talking with Chris, and he's saying that's kind of what. So what did you get when you highlighted just the left side?
You get, if you just do left side, you get 0.184, which is right.
Yeah, that's what I got. 0.184.
you highlight both sides, then you get 0.368. So that's why I put the first time. It wasn't right. So I guess I know something now. I need to read the question. Well, thanks for clarifying that.
All right. Yeah, it confused me too, because you would think that you would take the average of like both sides, but yeah. So number 17, what inference would you make about the null hypothesis for this problem? Which one would you pick, Anna?
Hold on, give me a second. So failing to reject the null hypothesis, p-value, then you say failing. It's so confusing. Why do they have to say failing to reject?
Yeah, because that's something.
Someone who speaks English as a second language. It's just like negative 2 times. So to think twice.
I think it's because you're never allowed to. You don't ever want to say that the null hypothesis is true. Because you always want to try and disprove it. So you either fail to disprove the null hypothesis, or you were able to gather enough evidence to reject it completely.
Yeah.
Yeah, like guilty or not guilty. I read that part. It kind of makes sense, but I still have to like when I read it. Okay, so I got here 0.1841. Is that right?
No, because you want to do it to the 3 decimals. So just
delete that one.
Oh, so 0.184.
Yeah.
Is that right?
Yeah, that's what I got.
Great. Will be, since it's bigger than 0.05, when it's bigger, then it fails to reject the null hypothesis. So if 17 will be the second one, right?
Mm-hmm.
Woohoo! What is your conclusion for this problem? It's not my most favorite thing. Now the option is not there. We have insufficient evidence that the true population mean is 150. We fail to reject the null. Meaning that the null hypothesis is true.
Yes.
So we have insufficient evidence that the true population mean. We have insufficient evidence, right?
Okay. Yeah. Okay.
It's 150. So that's the null. We didn't have enough evidence.
So yes.
So yeah. So is that one right?
Yeah, that one's right.
Okay. There are 2 types of errors that can performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I watched the videos.
Oh, good. Those are nice. Those are good to watch.
They made that little square, right? Which one involves rejecting the null hypothesis?
It's confusing when you like think about it too much.
I agree. It sounds confusing a little bit.
I don't know. I need to look at the book. I don't remember.
So, okay. So in the book.
I can tell you it's not type 2.
Yeah, it's not type 2.
That's what I put. Yeah.
Yeah, I put the same thing.
So it's type 1?
Yeah.
It is in the book.
It is in the book. So, type 1 error is committed when we reject a true null hypothesis. Another problem that can arise is to fail to reject the false null hypothesis. So if we fail to reject it, the correct decision would be a type 1 error or something like that. So that's kind of how I came up with it. I kind of was looking around and I was like, well, this has got to be the one. This has got to be it. I'm going to go with this one. It was right, but.
Which one involves rejecting the null? When the null hypothesis is true.
Which one involves rejecting
type
the
1
null
is
hypothesis?
when you have these hypotheses, like Anna has, and then someone comes and says, no, she doesn't have 3 kids. So you are committing a type 1 error, have 3 kids.
Basically, right? when the null hypothesis is true, and or when you reject the null hypothesis, when the null hypothesis is true, it's a type 1 error. But if you fail to reject the null hypothesis and the decision is false, then it's a type 2 error. So, does that make sense? I think you just kind of have to memorize that kind
of. Okay, 20. A researcher decide that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true? Of a type 1 error will increase. The error will increase.
This one, I mean, I got it right, but I wasn't for sure like how I got it right. So I read through the book a little bit, a couple times, and I was like, well, there are other common choices that you can choose for your level of significance. You can choose 0.1, or in this case, 0.01. It doesn't necessarily tell you what type of error it is, and I was like, well.
So the probability that the null hypothesis is true will decrease.
Well, didn't we fail to reject it?
Yeah.
Which would have been, that means if you fail to reject, it's type 1.
Right, so if you...
Then if you have type 2 and you do reject it, because it's greater than 0.5, then it now becomes type 2? Or no, is it the other way around? Sorry, I don't want to confuse you.
No, not confused. But I put type 2 error will increase. Yeah. That was right.
I'll be right back. I'll go grab our tutor.
Yeah, go get him. That's awesome.
Have him explain this, because I'm a little.
Yes.
I don't remember studying this part, like reading it. I was probably sleeping in this part right here.
No, but it's not really in the book.
Like,
so.
Yeah, how influenced the significance. I remember in the video he said it was like on the left or the right. It's like, what is the probability that's like extreme? So if you have 0.05, 0.01 is smaller. It's less the probability. 0.05 is bigger. 0.01 is smaller.
Then type 2 would increase.
Have you seen? There's a little there's a little chart that you can look at. So what alpha represents? What alpha represents is your confidence. It's called your confidence interval.
Okay.
What that means is that if you have a confidence interval of 0.05, it means that after you run all your tests, your statistical tests, and let's say your p-value was less than, it was like 0.05. That means that you have a 90, you can say with 95% confidence that that's the answer. But the higher you make the that confidence interval, the more the more likely it is that you're going to let's see. Yeah, the higher or the smaller that alpha is, the higher the higher the probability is that you are going to guess something that is, or you're going to be let's see. Type 2 error is when you reject something that you shouldn't reject. Is that right?
Yeah, type 2. Type 2 error is something that your decision is false, but then you fail to reject your null hypothesis. So the null hypothesis.
So type 2 is when you fail to reject something that you should have, correct?
Right.
Or is it you rejected something that was actually good? I always get it mixed up.
Can you say that again? Your voice was cut.
One or the other. I'm gonna see if I can find it. Let me see. Is she sharing her screen at all, or no?
Anna is, yeah.
Yeah, you take it off.
She is sharing it. Sorry, I was looking at my quiz.
Where's yours?
Right here. That's her screen.
Okay, that's your screen. Okay, let me look at just a second.
You can share yours now if you want. I just
okay.
He's using Google.
I'm using Google. Just a second.
Oh yeah, share that chart.
So let me. Thank you. You look tired, Anna.
I should be in bed. I should. I'm awake. I don't know, 4:30 in the morning.
Oh, yeah.
So I'm tired.
All right. Can you? I don't know if that's big enough to see. So let's see if I can find it one that's a little less confusing. All right, this one is more clear. I like this one. So reality versus what you measure. So if what you measure is true, whatever you measure can be true or false. Like it's true that it's your SAT score is 800, or it's false, right? Or the average SAT score is 800 or whatever it is, or it's false, and that's the reality. However, if you measure that correctly and it's true, then great, then you're correct. If you measure it and it's false and it really is false, then that's fine. However, sometimes when you measure something, you measure it and it's true, and you say, oh yeah, that's true, thumbs up. However, it's actually not true. It's like saying, oh, I measured it at 600 SAT score, but it's not really 600.
So is it just the opposite of what we figured out in the problem?
So type 1 error is when you have what's called a you measure something that is true but it's not true, and then when you miss something, when you so that's when you miss something, like there's a problem and you didn't catch it, is type 1 error.
I know, but
so when you go back to the question, and type 2 error is the opposite of that. So
researcher decided instead of using
right. So if you are being more stringent, that means you are being more critical. It's harder to get something that's acceptable.
Okay, so explain it to where it's like so this is that the original problem?
Go back to the question.
Oh.
Because this is really confusing stuff. It's like kind of, I don't know. So if
I thought everything was confusing, but if you think it's only 20, it's okay.
so for example, if you
right there,
if alpha increased,
why is that the
answer? That's what I was using that table for. So if alpha increases to, let's say, 0.1 or 0.5, something really big, it means that it means that you'd pass your test really easily. However, the reliability in saying that you passed your test, you would pass it, and it's very possible that you say, yes, I passed it, but you really didn't. So if you go back to this one,
that makes sense.
It'd be the reality. So type 2 error in this case is the opposite direction. It means that you said, oh, I didn't pass my test, but in reality you did. So if your alpha gets smaller, it means that there's a greater chance that you're actually, the reality is that it's true, but you think it's not true.
So because it's greater,
so because your alpha is smaller, your probability has to be higher in order for it to pass the test. So that's why your type 2 error would increase, because as alpha gets smaller, type 2, your probability that you're going to not accept something that you should have is going to increase.
Okay.
I don't know. It's hopefully, if you're ever confused, look at a table like this, and it helps you think through it. Alpha is your acceptance. How easy is it to or like how your acceptance rate, I guess. So the bigger it is, as in as it gets closer to 1, it's going to be you are going to be accepting things that are not true. If it gets closer, the closer it gets to 0, you're going to be rejecting things that are actually true. Like, anyway, does that make sense?
Yeah,
so
I
if
understand.
you have a bigger alpha, like 0.05,
So this is when alpha is getting smaller.
Yeah, type 1,
right? So as alpha gets smaller, like this,
you will be a type 2.
It's the chance that you commit type 2 error, which is this one, increases.
Okay.
Because you reject it when you shouldn't have rejected it.
Okay.
So the type 2 is kind of like the pessimist one.
Yeah. Yep. Type 2 is pessimism. It's you don't believe it. You're a lot more optimistic. A good example of this is in like airplanes. So when someone designs an airplane, they use statistics in order to make sure that the parts are really accurate. So that's why airplanes are so expensive, because they have to reject a lot of parts, even if they're fine, because because their alpha is so small. It's like 0.001. It's really small.
Okay.
So I don't know if that helps at all. But that's
yes, it does. I'll remember like that. The pessimistic one is the type 2. It's the one that like thinks just
Yep.
It's like, that's right. That's correct.
Yep. That's a good way to think about it. So type 2 is pessimism.
So type 2 is mom. Type 1
is dad.
dad.
Oh, he's fine. He doesn't need to go to the doctor.
Okay.
Thanks, Chris.
Finished, so we can go. Thank you so much. So the last one is 21, and it says if alpha 0.05 compute the probability of committing a type.
Do you want to share your screen again, Anna?
Oh yeah, sorry. Where was I? You guys have it?
Yeah.
Yeah. You're good.
Okay. So if alpha is 0.05, compute the probability of committing a type 1 error. I don't know how to. So what am I looking for? Compute.
Well, the answer is just 0.05. So I think that would be the probability is.
Yeah, because that's the p-value of a type 1 error. So.
Oh, it's telling you the answer already.
Yeah.
So the type 1 error, optimistic. Compute the probability of committing a type 1 error. Very good. Oh. What did you get? Okay, I'll just 0.05. Okay. How do you come up with that one? To compute the probability of committing a type error. You don't have to tell me. I can look.
So I came up with this one because I was like, okay, so how do I do this? And I was looking through. I was on the problem for a while, trying to think about it, and basically, It says here, we choose the alpha to some small number so that the probability of committing a type 1 error is low. So the most common value is 0.05, which is 1 in 20, which is 1 divided by 20, of course. And that's the chance that you will be rejected at the 0.05 level of significance. And so that's kind of how I got that.
There it was.
Good job, Anna.
Today's the quiz on Saturday. How many classes are you taking?
8. Not 8 classes, sorry, 8 credits.
Oh, 8 credits.
Yeah. But I only work part of the day, and then I just do my homework in the mornings. Like, I have no social life. I feel bad sometimes for my son because I'm like, go play with your toys.
Oh, goodness.
Well,
guys, thank you then.
Yeah, thank you. We'll see you on Tuesday then. Do you guys want to do the morning time?